Hi, this is Dr. G. Vikas Paul. In this session, we'll discuss about the Kani's method, the problem on Kani's method. Determine the support moments at A, B, C, D for the continuous beam using Kani's method. Draw bending moment diagram. So you can see a continuous beam here with point loads and UDL. So in these type of problems, the first step is to find out the fixed end moments. In the second step, we will find the relative stiffness K and U equal to minus of K by sigma K. And then in third step, we will draw the Kani's table and we'll find the M dash rotational components. And then in finally we'll find the moments, final end moments, and then we'll draw the bending moment diagram. So here first step is determination of fixed end moments. So our aim is to find the final end moments MAB, MBA, MBC, MCB, MCD, and MDC. So determination of fixed end moments, MFAB equal to minus WAB square by L square, MFBA is WA square B by L square, MFBC minus WA square by 12, MFCB, similarly MFCD, MFDC. We need to consider the intermediate supports as fixed supports. In the next step, second step 2, we'll calculate the relative stiffness K and rotation contribution factor U. So joints are B and C, members are BA, BC, CB, CD. Relative stress K is, K formula is I by L and 3 by 4 I by L. I by L is for 3 by 4 I by L. K equal to 3 by 4 I by L is for when the far end is fixed free. When the far end is free, it is 3 by 4 I by L. Remaining K equal to I by L. Fixed pin support or loader support, whatever it may be, it is K equal to I by L. If it is free end, then it is K equal to 3 by 4 I by L. So applying that formula, we can calculate the values. Then so I check I for it may be I 2I for different spans A, B, B, C and all. Next sigma K we can find, and sigma K BA plus BA value and BC K value. There you can write sigma K like that. So CB K value and CD K value, you can write here sigma K below it. Next U. The formula for U is minus of K by sigma K. So UBA equal to minus of KBA by sigma K, UBC equal to minus of KBC by sigma K. So we can calculate U values also, rotational contribution factors. Next, in the next step, we will draw the Kani's table and find the M dash values, rotational components. So here the first procedure is, first of all, we need to draw the given figure, continuous beam, and under that A as it is fixed support. At B we need to draw like this, you can see in the figure. And at C we need to draw some box, and then D as it is. And then first of all we need to write fixed end moments which were calculated in step 1. MFAB values at A and MFBA at this left side of this box, right side of this box MFBC, similarly MFCB, MFCD, MFDC at D. These values we need to write first. Then at the center in the middle exactly here minus 71.3, 69.16 is the sum of those moments, fixed end moments, MFBA plus MFBC. Here MFCB plus MFCD. Then we will write the rotational contribution factor values UBA, you can see here, UBC, UCB and UCD values, how we have written, you can see here. Then we need to write the M dash values, M dash values under them, like under A we need to write M dash AB, under B to the left side we need to write, means under MFBA here at the below we need to write M dash BA, then M dash BC, M dash CB, M dash CD, M dash DC we need to write. And now we will calculate this M dash. So we need to calculate the M dash values cycle 1 iterations by performing various iterations. Cycle 1, you can see cycle 1 here, and the formula is M dash BA, M dash AB is 0 here, and M dash DC is also 0. Then M dash BA equal to UBA into sigma fixed end moments plus sigma far end moments. So UBA value we know, here we have written minus 0.16 in that left side box. So then fixed end moments, sum of fixed end moments means MFBA plus MFBC here. Then sum of far end moment means, for B the far end moments is M dash AB and M dash CD, therefore M dash AB plus M dash CD. Then we can write it. So now we have not yet found these values, therefore we will write 0 plus 0. Now we got M dash BA. Next M dash BC equal to UBC into sigma fixed end moments plus sigma far end moments. So UBC we know, sigma fixed end moments also the same, minus 77.37. Then sigma far end moments means, so for B it is the same, sigma far end moments. So therefore M dash AB plus M dash CB. So 0 plus 0, still we have not found, therefore 0 we need to take. Next M dash BC we have got. Next M dash CB. So here UCB into, that means minus 0.25 into sigma fixed end moments, means MFCB plus MFCD plus sigma far end moments. So for C's, the far end moments are M dash BC and M dash DC. Therefore M dash BC we have calculated 25.53 in the above. Next M dash DC we have not, M dash DC is anyhow 0. Therefore now we got M dash CB. M dash CD equal to UCD into sigma fixed end moments plus sigma far end moments. Sigma fixed end moments means MFCD CB plus MFCD. Sigma far end moments means M dash BC plus M dash DC. M dash DC is 0. So we got M dash CD here. So first cycle is over. So whenever we calculate the M dash values, as soon as we calculate, we need to write under the table. The values we need to write under the table. Yeah, now this is the second iteration, cycle 2. In the same way we can calculate the M dash BA, M dash BC, M dash CB, M dash CD, M dash BA. But here the important point we need to remember is we need to take the values of a previous iteration. That means in cycle 1 what are the values we have got, that values we need to take here while calculating sigma far end moments, M dash AB, M dash CD, you can see here. So in this way we can calculate cycle 2, and then here we can see the cycle 3 iteration also, the values of cycle 3. Yeah, these are cycle 3 M dash values and cycle 4 M dash values. So we need to remember is as soon as we have calculated here, we need to write under the table. So how many cycles we have to do means up to till we get the same values. So in cycle 3 and cycle 4 we got M dash AB, M dash BC, all the values we got almost similar values. So then we can stop the iteration process. Then we can take them as final M dash values, means rotational components, rotational component, not final end moments, rotational components, M dash values. Now in step 4 we will calculate the fixed end final end moments. Calculate this is final end moments. So final end moments is equal to fixed end moments plus 2 times the rotation contribution, contribution at near end plus rotation components at far end. That means MAB equal to MFAB plus 2 M dash AB plus M dash BA. So MAB equal to MFAB we know, so M dash AB we have calculated 0, M dash BA we have substituted, so we have got MAB. Similarly we can calculate MBC, MFBC plus M2 times M dash BC plus M dash CB, we can calculate MBC also. Similarly we can calculate MCD, MDC also with the formulas. So as we have calculated final end moments using Kani's method, next to find, as he is asking to find draw the bending moment diagram, we will need to draw the bending moment diagram. So step 5 is bending moment diagram. Calculating the maximum bending moments. First free bending moments. So we know for point load and for UDL what are the formulas. Substituting them we will get the maximum bending moment values. So let us draw them first, and then we can add the final end moments there, and the net bending moment diagram is shown as in the figure. Thank you.